When you think about forensic science, what's the first thing that comes to mind? Probably microscopes, right? Or maybe DNA sequencers? But what if I told you that the integrity of justice actually begins long before a single sample is analyzed? It starts with the building itself. In this explainer, we're going to dig into how the very architecture of a forensic lab is the first and maybe the most important line of defense in protecting evidence.
So think of this as a tour through a state-of-the-art forensic facility. We'll kick things off with the foundational principles, then we'll walk through the all-important evidence intake zone. After that, we'll explore how contamination is controlled through smart design, tackle the tricky world of digital evidence, and wrap up by looking at how you design a lab that's ready for the future.
All right, so let's start with the big idea here. The physical layout of a lab, it's not just about making sure people have a place to work. No, it's a fundamental piece of the justice system itself. It has a direct impact on the quality and integrity of every single thing that happens inside those walls.
This quote really hits the nail on the head. A lab's design isn't just a nice-to-have, it's an absolute prerequisite for justice. It has to do more than just provide a workspace. It has to create an environment that actively enforces those tough accreditation standards like ISO/IEC 17025. That's how you make sure every piece of evidence is rock solid and can stand up in court.
Every single piece of evidence, no matter what it is, starts its journey at one critical checkpoint, the intake zone. Let's take a look at how this space is designed to be the ultimate gatekeeper.
One of the most important concepts for intake security is something called unidirectional flow. Basically, the lab's layout is a one-way street for evidence. This isn't just a suggestion written in a manual. It's physically enforced by the architecture. By making it impossible for evidence to backtrack into areas that are less secure or maybe already contaminated, the design itself becomes a guardian of that chain of custody, right from the second an item walks in the door. And the details here are just critical. For instance, the lighting in the intake area is specifically designed to be at least 100-foot candles. Now, why so bright? Well, it's so technicians can immediately spot tiny but crucial problems, like a small tear in a bag or a broken seal on a container, things that could totally compromise a case later on. It's all about seeing everything right from the start. So the intake zone has all these layers of security built right in. You've got pass-through lockers, so evidence can be transferred securely without direct contact. There are airlock systems, sometimes called man-traps, that strictly control who goes in and out. Even the air is engineered. Negative pressure ventilation helps contain any particles from evidence that hasn't been sealed yet. Every single feature is a deliberate choice to protect the lab, the people, and the evidence.
Okay, let's move a little deeper into the facility now and look at how the very air you're breathing is engineered to stop contamination in its tracks.
This is a fantastic example of that old saying, form follows function, but for HVAC systems. Think about a DNA lab. Before you amplify the DNA, you've got this tiny, super sensitive sample you need to protect. So you put it in a positive pressure room that's constantly pushing air out, keeping any contaminants away. But after you've made billions of copies of that DNA, that new material is now a huge contamination risk itself. So you work with it in a negative pressure room that pulls air in, trapping those amplified products so they can't escape and contaminate other evidence. It's pretty brilliant.
Now, besides airflow, temperature is a huge preservation tool. The National Institute of Standards and Technology, NIST, recommends storing DNA long-term at or below -20 degrees Celsius. And this isn't just about keeping it cold. It's about literally hitting the pause button on the degradation process, making sure that biological evidence is still good for analysis years or even decades down the road.
And as you can see here, there's absolutely no one-size-fits-all solution. Liquid evidence needs to be refrigerated to stop bacteria from growing. Debris from an arson scene needs a cool, vented space so those volatile chemicals don't just evaporate into thin air. Each type of evidence demands its own specific, highly engineered environment. A well-designed lab is really a collection of these perfectly controlled microenvironments all housed under one roof.
Okay, so far we've been talking about physical and biological stuff. But now, let's pivot to a totally different kind of challenge, protecting evidence you can't even see. This is really the million-dollar question for digital forensics. A cell phone or laptop isn't just a static object. It's a live device, constantly trying to connect to a network. The threat isn't just somebody touching it. It's a remote command that could wipe out all the evidence in a split second. So how on earth do you use architecture to fight that?
Well, the answer is a Faraday cage. It's basically a room built with special conductive materials that creates a bubble, completely blocking all external electromagnetic signals. No Wi-Fi, no cell service, no Bluetooth, nothing gets in or out. This lets an analyst power up a device and start their work without ever having to worry that someone on the outside is going to send a remote wipe command. It's a physical shield for a digital threat.
This all leads to the idea that the server room has really become the new evidence vault. I mean, it needs the same level of physical security you'd see in a firearms or drug vault. We're talking hardened walls, biometric scanners, but it also needs specialized protection, like clean agent fire suppression that puts out a fire without destroying all the electronics, and of course, backup power to make sure that crucial data is never, ever lost. It's a true fusion of physical and cybersecurity.
Okay, let's head into our final section. We've seen how to secure the evidence of today, but what about the evidence of tomorrow? Great design has to plan for the unknown.
This is such an important point. Forensic science changes so fast. A lab that's built today might need to be in service for 30 or 40 years. Can you imagine the tech changes we'll see in that time? If you build a static, unchangeable lab, you're basically guaranteeing it will be obsolete. The real goal is to build a facility that can grow and adapt to new instruments, new workflows, and even whole new types of evidence we haven't even thought of yet.
So how do you do that? It all comes down to building in flexibility from day one. Instead of heavy, fixed benches, use modular casework that can be reconfigured, kind of like Legos for a lab. You build in IT infrastructure and utility grids that can handle more powerful equipment in the future. You even design hallways around the perimeter of the lab spaces so maintenance can happen without ever having to disrupt a secure area. It's all about being ready for change.
So we'll end with this question for you to think about. A lab's design is its silent partner in the search for justice. It's a whole system of controls that guides workflow, prevents contamination, and locks down the chain of custody. It's not just a building. It's one of the most fundamental instruments we have in forensic science.